In section 6.2, we'll be talking about graphs of exponential functions. A characteristic of the graph of the parent function f of x, which is equal to the base b with an exponent of x. An exponential function with the form f of x, which is equal to b to the x, where b is greater than 0 and b does not equal to 0, has these characteristics. Well, first and foremost, it's a one-to-one function, so it passes the horizontal line test. It has a horizontal asymptote at y equals 0. The domain of the function goes from negative infinity to positive infinity. The range goes from 0 to infinity. The x-intercept, there are none because it doesn't cross the x-axis. The y-intercept is at 0, 1. It is an increasing function if b is greater than 1, and it's decreasing if b is less than 1. And then figure 3 compares the graphs of exponential growth and decay functions. So this graph, since it's going from left to right, it is a growth function. And on this side, it's going to be a decay since it's decreasing from left to right. So in example 1, we want to be able to sketch the graph of an exponential function of the form f of x, which is equal to b to the x power. So how do we do that? Well, given an exponential function of the form f of x, which is equal to b to the x, we're going to graph the function. Number 1, you're going to create a table of points. Number 2, you're going to plot at least 3 points from the table, including the y-intercept. In step 3, we're going to draw a smooth curve through the points. In step 4, we're going to state the domain, negative infinity to infinity, the range 0 to infinity, and the horizontal asymptote y is equal to 0. So in example number 1, we want to sketch the graph of f of x, which is equal to 0.25 to the x power. And then we're going to state the domain, range, and the asymptote. Now, before graphing, we want to be able to identify the behavior and create a table of points for the graph. So we need to look at what the base is of that function. Now, since the base is equal to 0.25, and it's in between 0 and 1, that means that we know that the function is going to be decreasing. So the left tail of the graph will increase without bound, and the right tail will approach the asymptote y is equal to 0. And so now what we're going to do is we're going to create a table of points. So we're going to pick our values for x. So since on our graph we can pick some negative values going from negative 3, negative 2 to negative 1, 0, 1, 2, and 3. And what we're going to do is we're going to plug in each value for x and find out what the output is. So over on your calculator, we can put in parentheses the base, which is 0.25. And then we're going to raise it to the exponent of negative 3. And what we get is 64. If we do the same thing again, we're going to put 0.25 as our base. And now our x value is going to be negative 2. And that gives us 16. If we do it again, we got 0.25. We're going to raise that to the negative 1 power. And that's going to give us 4. And if we put 0.25 and raise it to the 0 power, anything to the 0 power is always going to give you 1. And then if we put in 0.25 and raise that to the 1 power, anything to the 1 is going to give it itself, so it's 0.25. And then we're going to take 0.25 and raise it to the 2nd power, which gives us 0.0625. And then we're going to put in the base to be 0.25 and raise it to the 3rd power, which is going to give us 0.015625. Now we want to plot the y-intercept 0, 1 along with the 2 other points. So we want to make sure that we can graph something on the left side and graph something on the right side so we can at least see what the direction of the curve is going to be, even though that we already know what it is according to what the base is. So we plot the points on the y-intercept, so we have 0, 1. We plot another point, which is 1.25, and then we plot another point, which is negative 1 and 4. And then what we do is we draw our smooth curve with arrows at the beginning and the end. And again, the domain in all the x-axis values are negative infinity to positive infinity. and the range is going to go from 0 to infinity. So again, the domain is negative infinity to positive infinity. The range is 0 to infinity. And the horizontal asymptote is at y equals 0.